7 just gets to chill, right, cool kids? The coefficient, the 7's just going to hang out for the ride or be along for the ride. I'm going to go ahead and get my other marker because I don't like that one. Okay, cool. Equals 7. Woohoo! Fuzzy, what do we do with the power rule? What happens at x to the 12th? But you have to think ahead. If you were to derive this, what else do you need to be ready for this power rule? Over 13. And then don't forget to put your plus c. Therefore, final answer is, you can either write it like that, or you can say 7/13 x to the 13 plus c. Dun, 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 dun. Who has it right? Put a check mark on your paper. Did you get it? What is the rule that led there? Wasn't it x to the n plus 1 over n plus 1 plus c? Yeah, it was. The second one, that 5 is just hanging out for the ride, right? But after that 5, man, we need to know what our derivatives backwards are. Lucas, what is the integral, aka the antiderivative of sine of x? Oh, why is Lucas putting a negative with the cosine? I thought the derivative of sine, yeah, the derivative of sine is a positive cosine. But if you are deriving what you have, what's the derivative of cosine? So I need a negative to be ready to make it positive, right? This next one, why am I going to put a minus right away as soon as I see those c's? Yeah, to account for something. And hey, what's the derivative of anything with c's? Cosine, cosecant, cotangent. Every single derivative is a what? Negative. I know this comes from cos. I know this comes from c's. Which one, though? Is it sine or cosine? Nah, they just go back and forth on each other. Is it secant or tangent? Nah, because I need the c's. So I have two options. You have a 50% chance of getting it right. It's either cosecant or it's cotangent. Before I answer that question, or before I ask someone to answer that question, does anybody know the derivative of tangent? Secant squared. So the derivative of cotangent is going to look like that and be a squared. Is that a squared, everybody? No. So it's not cotangent. Who's the only guy left standing? Cosecant. If you know the derivative of tangent, you should be able to get there. The derivative of tangent is secant squared. So cotangent works like him. It'd be negative cosecant squared. The derivative of secant is secant tangent. The only guy left standing is cosecant. Double check though, what's the derivative of cosecant? It's a negative. There's also a negative that will make it a positive. Cosecant, cotangent. Oh no! I've messed up. What do I need? Let's see. Whoop, 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 whoop. This one, I am not starting with red. I am starting with black because what do I need to do before I ever integrate? Rewrite. And doesn't your homework have like a whole rewrite section on some problems to tell you? Now, Hovan asked a really good question. He was like, that was your cue. What were you asking me for this one?
I just asked if that 3 was x cubed or if it was the 4.
He was asking, is this 3 a third power of x or a cubed root? When you guys look at it in WebAssign, it's really clear, right? Like the radical and what's inside. So this might be a little confusing. I did tell him it was a cubed root. Since it was a cubed root, question, what power does that make that guy? 1/3. Why? If you take 1/3 of something, that doesn't work, because cubed you would think goes higher. 1/3 is cutting. Go to the 4th root is a 4th, 1/4. Go to a 5th root, it's 1/5. Oh, so cubed root is 1/3. I always think of the 4ths and the 5ths because those are fractions, and that might help you out. If you're not making that jump, but most of you are by this point. Hey, come to calculus to learn exponents. Go team. What is the power of x that we need to integrate? Yeah, 4/3. How'd you get it? This guy is what power? 3/3, and 3/3 plus 1/3 is 4/3. Look at you guys able to do exponents. Go team. All right, so what's that new power? Sarah, did you get here? You were doing these great in homework. Did you get to his new power? You do it now. Oh, she's going all the way, everybody. 3/7 x to the snap doggy dog, kid. Because I have 4/3, I'm adding 3/3. She was doing that in her head and got 7/3 maybe on her paper. And those 7/3 I need to account for and be ready with the reciprocal. You guys got it? How many check marks are on your paper right now? Wait, pause. Did you give yourself a check mark for all the ones you got right? How many? Is it 0? Is it 1? Is it 2? Is it 3? Show me, show me, show me. How many? Okay. 0, 1, 2, or 3? Okay. Mo, you doing all right? Give me a thumbs up on the screen if you're with us. There she is. All right, here we go. We are doing all of this to get you guys ready to go into, wait a minute. Hold on, I have extra slides before our integration competition coming after our WebAssign. Hold on. Something funny showed up in homework. So here's a question. What if you had something like, let's do like 7 plus x cubed. Whoo, Andy, you see what I'm shouting out to, right? What if you have a division? Is there a quotient rule for integration? Yes or no? No. So we're staying in your homework spiral. Number 4, we're ending right here with our warm-up. Before we go to WebAssign, what if we have division? What do we need to do? What can we do to rewrite? I'm not going to red. I'm not solving it. Yeah, I can think about it as an x to the negative 1 if you like thinking about it like that. And we could distribute. What's the other way of thinking about it? We could also split up the division and we could distribute the division because division is really multiplication by a reciprocal. I distribute multiplication. Whoa, did you hear that? Division is really multiplication by a reciprocal, so I can distribute division. I can distribute x to the negative 1 or I can distribute division. Can anybody tell why I might actually like this version better than that version? I'm not saying this is bad, I'm not saying it's wrong, I'm not saying it's off. This totally works, but can anybody tell? This was one trick, this was one, like just the division itself, but there's one other, Sarah, do you see it? There's one other thing coming. Victor, what do you see that I'm kind of like, oh?
Can you simplify it?
I can simplify this, yeah. And some people could probably just do this right here and say like, oh, hey, it's 7 over x and it's x to the power of 2, which you would get here. 3 minus 1 is 2. But actually, that's not what I'm worried about. I'm actually worried about something else. And I think this top one might have you get it wrong, whereas the bottom one might have you get it right. Why do I like this version of that better than this version of that? Okay, if we were to go ahead and simplify this one on top, how would you solve the integral? It's going to get small. Woohoo! 7x to the negative 1 plus x squared. What rules would you use? Power rule, yeah, make it x to the 3 over 3 and make it x to the 0 over 0. This is the exception to the power rule at the very beginning of all of these formulas, which some of you guys can see on the screen and some of you might not be able to. There is an exception to the power rule. Why does it say the power rule is great for everything but x to the negative 1? Who deals with x to the negative 1? But you don't think of it like that. You think of it as 1 over x. What's the derivative of ln of x? 1 over x. So what's the integral of 1 over x? Ln of x. But oh, careful, it's ln of absolute value of x plus c. ln says I deal with the negative 1. That's my derivative. Power rule, back away. But thank goodness the power rule doesn't work for these. Because if I tried the power rule right here, I would get a to the 0 over 0. Whoop, that didn't work. Exactly, because it wasn't supposed to work. The final answer is supposed to be 7's just a coefficient. If you guys need to think about it, you can rewrite this as a, I shouldn't rewrite that in red. You could rewrite it as 7 times 1 over x. The 7 is just a coefficient. But 7 ln, I didn't think we got many ln's in our notes, so I was like, wait. 7 times 1 over x goes back to an ln of absolute value of x, and then I have a 1/3 x cubed plus c. This one wasn't to get it right the first time. This was to learn in the midst of us doing it a couple different techniques to be, well, one technique, as far as pick which one makes sense. You'll be okay either way. If you try the power rule, it's okay. Because you should get stuck and then be like, oh, that's right, ln. I just kind of like looking at it the other way, because then I start to get used to a 1 over x leads me to ln. Just don't forget your absolute values. It's part of the... Sorry, a couple of you are still writing, my bad. It's part of the charm. All right, WebAssign. No, not really, it's just a rule. WebAssign. Oh my goodness, I took extra time. You only have 10 minutes until your assignment locks out. Did anybody notice that I just changed it to 3:30? Not because I want to encourage procrastination, but because it can be a bit tricky. Some of you got grace that maybe you didn't deserve, or maybe you did. Well, you don't really deserve grace, that's not exactly its definition. But either way, you all get to benefit on WebAssign and Google Classroom. You have until 3:30, but I'm not spending that long doing homework questions. I'm still just spending 10 minutes, and that's it. So where are we going in homework? Last 3. Hey, Sarah got it in. Nobody else was ready for where I was headed. Siri, I'm not talking to you. Shush. All right. Doop, doop, doop. Number 14. Number 14 looks an awful lot like an initial value problem. Well, that's not the screen I want. That's the screen I want. I'm going to the end of your... Ooh! 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 What's going on here at the end of the slides? Competition probably won't have time for, but you need to stay sharp on integration all the time. So this is probably coming on Friday. You guys are going to the boards in your groups. Every problem someone new has a marker, and the other people can only speak advice. They can't actually take the marker from you. And we'll compete through 4 different problems, seeing which team wins for bonus. Then, probably next week, we're going to do an integration quiz. Like a pop quiz, but it's not really a pop quiz because I just told you about it. All right, homework questions are here on slide number 20. Friday, we're getting to the boards and you're playing around with integration by at the boards competing like we did with derivatives. Remember how we competed and like you were trying to get the marker and do problems? No, that's just practicing some more. And then once we've done what we did today and the homework questions and then the competition on Friday where you guys are able to talk to each other through problems, then Monday, no, that's an A day.
I'm not gonna be here. Wait, are we having
But it's going to be A, B, it's still next week is the 31st, it's still technically January. So it's A, B minimum day. I don't know why, it's just... Then chapel starts the next week, I believe. Homework questions. Wait, guys, I said 10 minutes, and now it's only 9 minutes. Let's go. Actually, it's more like 8 minutes. Here we go. Oof. Sarah, that was a good question, whether or not you realize it. What are they giving you to start off this problem? Which derivative? Oh! Okay, so if I'm integrating a second derivative, what am I going back to? The first derivative or the first function? One integral will take me where? The first derivative. One integral goes back one derivative. So if I am taking the integral, I'm getting to f prime. I'm not getting all the way to f. But they want me to solve the differential equation. Now guys, this is vocab. Remember, I'm exposing you to vocab. I told you last time that we will keep working on this vocab. But when it says find the particular solution, it's not telling it outright. What it means is solve for y equals, and I think, Victor, you asked me this one? Maybe, last time? It might not always say this, and it's just understood by the vocabulary. So we'll keep working on it. We have a whole section on it. But just for you guys to know, when it says solve for the differential equation, it says go all the way. This isn't going to get me all the way, but it's a step in the right direction. Cool, kids. Power rule. We just practiced it. Add one. Ooh. Does that go to 5 halves, or does that go to negative 1 half? If I add, isn't it going up closer to 0?
Yeah.
Wait a minute. Got to anticipate. Okay, pause. You could use the rule. n plus 1 all over n plus 1. You could use the rule. But I need to somehow make it look prettier. I have to integrate it again in just a second. What happens when you divide by a fraction? Yeah, like you heard Sarah do a second ago with that 2/3 and the 3/2. So flip it and you'll get negative 2 over 1 plus c. So what is my f prime of x? My f prime of x is equal to negative 2 over square root of x plus... Why am I pausing? I rewrote it. What am I supposed to be writing?
Oh, you don't need the plus c because it's the inner, it's the differential thingy or something.
You have to plug in.
It's not that I don't need it, it's that I gotta what? Plug in, and then I'm gonna have it be a number instead. So I'm not gonna, I don't want the plus c. I don't want it to stay c. Why? Don't I have a... I have a clue. Now, careful. Do you know what the clue says? Do you know that x is equal to 4? And the derivative is equal to 3? Would you put them in the right spots? Hopefully, right? So I can take this guy and I can say, okay, 3 is equal to negative 2 over square root of x plus c. Wait, square root of who? Oh, yeah. I should have plugged in square root of 4. Square root of 4. Woo! What is the square root of 4? Take it, Sarah, and say, yeah, come on, be the powered woman. So, square root of 4 is 2. What's negative 2 over 2? Negative 1. What does c equal?
It's 4.
Yeah, it is. So I'm putting 4 in this spot because I know what c is, right? Are we okay?
Yes.
Go do it again. All you gotta do is one more integral and use one more clue, and then you'll have f. Go, finish. Those of you that have it.
I figured it out now.
P.S. The deadline in homework just got extended, so if you're not on number 14, can't you be doing this in your homework spiral workspace and having it ready? Is it a bad idea to have your brain write a problem down twice? Oh, you guys missed that one. Oh, you heard that one, right? Is it bad to write down a problem twice? No, you're giving your brain extra exposure. Are we talking about my class or another class? If it's another class, it's not cool.
For correct.
Why is it correct?
Hey, guess what? I'm not finishing it for you. You guys keep going. Sarah, was there another question?
Yeah, can we do,
Pick one. Can you pick one?
yeah, we can do 16 then.
Cool. I'm going to freeze the screen for those of you guys that are trying to finish this up. For those of you just talking, don't worry. I'll get you busy in about 2 seconds because we're going to do the last problem. An evergreen nursery? Hoo-hoo-hoo. Watch it. This is not going in the Jamboard. You're only going to get it if you get it in class. Oh, snap. This next one, number 16, is not going in Jamboard. I don't have it as slides. It is what it is.
Oh no.
You'll be fine. Oh.
Will I?
As long as you get it in class, you'll be fine. Huh. Okay, don't get lost. Homework all done? You're on motion, right? Yeah. Alright, here we go. Number 16 in 5, 4, 3, 2, 1. Here we go. Although, I'm only going to do number 16 if you guys quiet down so we can do it together. Starting the countdown for the quiet down. Oh, we focus when we want to. Here we go. You guys ready? Evergreen Nursery. Evergreen Nursery usually sells a certain shrub. Get me a shrubbery. Probably haven't seen that movie. After 6 years, it's not worth it. Of growth and shaping. Sells a certain shrub. Mr. Hampton would have seen it. After 6 years of growth and shaping. The growth rate during those 6 years is approximated by... Ooh! Who is this guy? And what did they just call it? You guys see... Right? Is in math is showing, I know, I did a movie reference. Growth, what though? The key is the rate part. The key is the rate part, but yes, it is growth rate. Okay, so what do we got? We got dHdt, and it is a rate, which means it is a derivative. Whereas I'm teaching algebra 1, it's a slope. Or a slope of a tangent line, where t is time in years, that could be helpful, and h is the height in centimeters, that could be helpful, and the seedlings are, why am I going to blue right now? Anybody know? It's the plug-in at the very end.
Oh, because the clue.
It's the clue. It's the plug-in at the very end. So wait a minute, what do we got to do before that? Hold on, guys, what are they asking in part A? No, we're finding the height. And what do we know? How do we go backwards from rate? Right? Let's go. We integrate. But we gotta just move that, remember, we need our indicator, move that dt to the other side. Yeah, like we move the dx. Move the dt, and all of a sudden this is set up and ready to go. All I need to do is get up here and throw in an integral and say, hey, as soon as I have everything all nice and organized, we're fine, whatever. You're an h? Okay, I'll integrate you with respect to h. You have t's? All right, cool, I can see that. So let's integrate you with respect to t. But when I integrate, aren't I going to have a plus c? Now pause. I go fast, but guys, you see the power rules, right? How can you double check I'm right if like your brain isn't keeping up? Take the derivative. What happens to that 2 when it comes down? Ooh, I anticipated, right? Derivative of 7t, 7, derivative of c, poof, there he is. Why am I getting my blue? Because what am I going to do? Yeah, but where do the numbers go? 16 is in the t spot or the h spot? Yeah, match it up. That's how tall they are, aka that's their height, right? Centimeters? So 16 is equal to, when t is what? Oh, that's when they're planted. You got them like that little baby shoots already. Isn't that a 0, and isn't that a 0, and isn't that a... Hey guys, be careful. Right here, be careful. Right here, you might be like, C is always the number they give me. Depends. It's usually the number they give you if they give you the initial, because zeros usually make zeros, right? Like plugging in a 0, plugging in a 0, those all went away. But I just said usually. Is there anybody, Joshing, is there anybody? They're working, it's fine. I just need quiet. Is there anybody that would take a 0 and not make a 0? Ooh, what's e to the 0? Careful. We plug in and we make sure. Does that make sense? At the end of the day, C is equal to 16. Oh my goodness gracious.
It's not bad. I promise.
Do you see my mental math going on? Because I knew 1.4 divided by 2 is 14 divided by 2 is 7, but there's a point in it. Anyway. Dun, 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 dun. Wait, what's part B?
Wait, why did you get 0.7?
Oh
my
God.
Oh yeah.
I said, yeah, did you get that? I was being too entertaining, Miss D. I'm sorry.
I'm sorry, Miss Michelle.
Part B! Sarah, now bring in what you were saying earlier. You said something about 6. Why'd you say something about 6?
That was the time that it grew with the years or something.
It is years. They're looking for how high it is after they sell it after 6 years. They grow that thing for 6 years. Well, it takes time to grow, right? So there are always like there's the seeds in the packets that you can buy and start from scratch. There's a little like seedlings, and you can buy the ones that you're really lazy. You're like, I just want it now. Immediate gratification. Oh dear. Let's not go there. Let's get the E gone. Sorry, he's not in this problem. But if this is when they sell it, then you guys should know what to do as far as how to finish the problem, right? Because what's the last guy says? He says, how tall are they when they are sold? And they just told me they sell after 6 years. They let it grow for 6 years and then they go.
So do you just plug in 6 to the A?
Why? Because 6 years is a time, and this guy says, I'll give you any height.
To the A.
Exactly. Plug it in, plug it in. I know that T is equal to 6. All I have to do is plug in. Wait a minute, wait a minute, wait a minute. What are the units and do they match? Centimeters is what I want, but I have years, right? I have years. Guys, just real quick, let me finish up this problem. I want to move on. If I have 6 years, does that work with my T? What is T measured in? So I'm okay. Woo-hoo-hoo. What if one was days and one was years? What if one was months and one was years, right? Whoo! Now, you want to hear something really crazy? Did anybody notice at one point that 4.1b homework was due today at one point?
Whoa.
It's no longer due today anymore, right?
Yay.
However, how did at least 2, if not 3, if not 5 classmates already start this homework? Oh, snap! Some of you are being challenged with how much you're getting done. Okay, stop. We don't all have to be the same. But how did some of your classmates get to start this homework? Have we talked about motion at all this year? Oh. Did you notice that this part of the notes starts off with the word what? Review! And it's green. Okay, review. Cool kids, let's go. Review. What do we already know without me going back to the motion forever card? Oh, actually, hey. Look, it's in the old forever cards. I can go back to it right now. But as I turn to it, someone tell me something that I will find when I get there. What's something on the motion card that I'm going to find?
Position.
Ooh, I am going to find the word position. What else am I going to find? Velocity. Good. What else am I going to find? What's the derivative of velocity? Time. Time will be on there for sure. Average versus instantaneous. I might have an average rate of change. What's that pedal in your car that makes it go vroom vroom? Gas.
Acceleration.
Acceleration.
Gas.
But yes. Yes. Yes.
Thank you.
Let's see. Position. Check. Velocity. Check. Acceleration. Check. Average versus instantaneous. Oh, I've lost a line totally to something that is not my class, but it is STEM. Speed. What's speed? I thought that's the same thing as that. In motion. What is speed and how is it related to velocity? You can read it. Read it out loud. Let's talk about it real fast. Absolute value, which means I'm shooting something up. Its velocity has what sign? Positive or negative?
Positive.
Let's make it not too crazy. So a marshmallow gun. I am shooting a marshmallow into the air. And it's going straight up. then my velocity is positive and my speed is positive. What if I shoot a marshmallow down into the ground? What is my velocity before it hits the ground? Negative, but what is my speed? Positive. Speed just says how fast. I don't care if it's up or down. Velocity says, oh, but I'll tell you which direction. Same number. One has signs that matter. The other one says, I don't care about the signs. Did we miss anything else? Oh, there were some things. Like, if something hits the ground, what do I know about its position?
0.
Unless the ground is the top of a cliff, then maybe it could be something like 100 feet tall and then the other ground is 0. It just depends. In physics, you can say you're 0, you're not. Okay, we'll talk about it. What if I say something like initial?
No.
Sorry, Mo, I'm out of the screen. Not that you really need to see me. But what if I say something like initial? I'm about to write all of this down really fast, but initial, I want you to think about it. Initial. If something is happening initially, what is my time if I say something is the initial?
0.
Yeah, time is 0. It's at the beginning. Last but not least, if I say something like it's not being shot, it's not being flung, it's not being propelled, but instead it's just being ready, mic dropped, right? What is my initial velocity?
0.
The velocity becomes negative because of something called gravity. But what is the initial velocity at the instant I let it go? 0. I'm not shooting it, so there's not an initial thrust on it. There's not an initial speed that it has. Instead, its initial velocity. Where is it? I don't know. Probably off the ground if you're dropping it. What's the acceleration? Well, gravity's acting on it right now. Just I'm keeping it from falling, right? But as soon as I let it go, initial velocity, it wasn't propelled, it wasn't thrown up, and then it came back down. Okay, let's write about all this stuff. Ready? So we have position. Whoop. We have position. Oh, that's weird. On the forever card, hold on, I'm saying what I want to say, but too early. Give me a sec. We have position. I'm going to call it S of T. But on the forever card, wasn't it the top thing I wrote? Huh. Then we have velocity. Interesting. Why is she writing everything backwards? Same 3 words, but why did I write them in a different order? This was derivatives. How do I go from here to here? Derive. How do I go from here to here? Derive again. But we're not in derivatives. I mean, they're still around. But what are we doing now?
Oh.
So couldn't I say then that velocity could be equal to the integral of acceleration? I can go the other direction as well once I know an integral. Andy, you're missing it. It's big stuff here. Physics. And position is the integral of velocity, or the second integral of acceleration. We're not doing double integrals. There's like this whole other thing. You can Google it. It's called Calc2. Calc3. Anyway. But the idea of taking 2 integrals, you guys can understand. 2 integrals you can understand. A double integral is a little bit dicier, a little bit trickier. Okay. Deriving is position to its rate, velocity to its rate, acceleration to its rate, jerk. Because you're jerking around in the car when someone doesn't know how to drive. But if I'm going backwards, acceleration to velocity to position. Now, we do have other things as well. So quick reminders, not bad to remember. Speed is always positive and always positive, like the speedometer on your car, regardless of the direction that you're headed. How do I say in math, always positive? Nice. Nothing else. You go to absolute value to talk about the speed of something. It was more than that, but that's okay. What else? We can do those reminders of initial. Ooh, I can't spell, but I was trying to write fast, but it's down here. Initial. T is equal to 0. Dropped. Don't judge, don't judge, don't judge. Initial velocity.
She disrespectful.
Me?
No, Miss G.
Oh. Initial velocity, I'm moving on. Initial velocity is 0. You guys remember we can use little subscripts to just kind of like say which one, right?
V
Cool.
naught.
Poor little algebra kids still need to learn that. They get really confused. Initial dropped. Oh. Hit the ground. Depending on what you're making the 0, we could say position is equal to 0. But it wouldn't be like
Does that say hit ground?
hit ground. Sorry. Look at you reading my cursive. Good job. But why is this such a big deal? Because what is gravity? So I'm going to use approximately. Let's not go into the fine caveats of gravity actually is different at different places on the Earth because the Earth is not perfectly spherical. Instead, let's just say in general. My physics people, you should know this. What is gravity approximately in feet per second squared?
1 meters per second.
Okay, you're saying this one.
Or 10.
Wouldn't it be negative 9.8 though, because it's pulling something down? Or what would it be in feet per second?
Dude, we're so used to using positive ones, man. Leave me alone.
Oh, because your formulas probably have negatives in it.
Exactly.
Got it.
Josh.
Remember, we think of where the formulas come from. How about the feet per second squared one?
Give me a second.
I'm trying. I'm giving you a few. Negative 32. I can make it rhyme. What? Okay. Don't worry, we're going to write it again. Why? Because there's something called free fall. Free fall model, free fall motion. What if we're talking about just gravity acting upon an object in motion? Now, we still have to keep it basic because of the level of calculus that we're in. Otherwise, we'd have to go to something called parametric equations. Oh, we kind of learned that last year, barely. Honors kids. But to keep it one-dimensional motion. Technically, we call it rectilinear. I think we talked about this last semester. Rectilinear means we're either just going up, down, or we're going right, left. Now, yes, we might take that up, down, and we might like map it across time or something. So we might take that up, down, and say, ooh, but you know, that falling is happening over time. We could show that, but we're not showing it's actually going on an arc. At least not with what we're able to do, because we're not doing like horizontal and vertical displacements at the same time. That's mostly for my physics people. Everybody else, just take a breath and say, she'll get us through. But rectilinear, we're just going up, down, right, left with our math. But here's the idea of free fall. Okay? Free fall, we're talking about stuff that gravity is acting upon it. So just up, down. Free fall, we're going to start once again with, we have a constant acceleration. And guys, it's not just the initial acceleration. There's no engine, there's no other outside force acting upon it. So it's like the acceleration is always and only for our, looking at the math of it all, situations. And it's what I just wrote. Negative 9.8 meters per second squared, or negative 32. Whoa, I don't know why I have that be a power. Sorry. Or feet per second squared. But physics people, you ready to see where your formulas come from? All we need is what gravity is. And as soon as we have what gravity is, we can get all of our free fall velocity and position functions by doing the following. We can say, hey, velocity is equal to the integral of, someone choose. Andy, what do you want, meters or feet? Negative 9.8 or negative 32? Meters? Cool. So we're going to say, velocity is equal to, from the page before, the integral of acceleration. The nice thing is that acceleration in this example with free fall models is just gravity. If I just integrate that constant, that's easy stuff, right? Because then I say, hey, it's with respect to t. Let's go ahead and throw that t on it, and then we're going to say plus c. But if we have this special guy called initial velocity, we can say that initial velocity is going to equal when time is 0. So guess what? C is just v sub naught. And that lands us at an equation for velocity, which is v of t is equal to negative 9.8 t plus initial velocity. When we're dealing with gravity. When we're dealing with only gravity. If we're dealing with some different acceleration, whatever, throw it in your integral, hope that they give you a clue, plug in the clue, and figure out your own plus c. But for ours, for freefall models, it's just gravity, it's just a constant. I will always land here. Plugging in 0 will always get me to c being the initial velocity, which is why physics people have this on some list of formulas, and it's like, sweet, use it, memorize it. But where does it come from? An integral. Position says, all I need to go back one more step is another integral. So position says, give me that velocity. It's like, okay, cool. Negative 9.8t plus v sub naught, which is a constant, equals. Hey, how do you integrate a constant times t? Up the power, cool kids. What do I get? T squared. So I'm going to have negative 9.8 t squared over 2. I'm going to end up dividing negative 9.8 and get negative 4.9. But another way of looking at that could be negative 1/2, whatever that acceleration is, t squared. Oh! But I'm just saying we know what that acceleration is. We're dealing with gravity, so I'm going to that negative 1/2. Technically, it's a positive 1/2, I suppose. But I was thinking of the physics people that have the negatives in their formula. They don't understand. But technically, this one says, hey, if you have a constant acceleration, you can always say that velocity is that constant acceleration. Or if you have a constant acceleration, you can always say the position is 1/2 that constant acceleration, t squared. But wait a minute, who's that plus c? Hold on. Given v sub naught, the initial velocity when the time was 0, we knew that c was that initial. We can do the exact same thing here, just we'll be given another clue. Like that number 14 that Sarah brought up, we did 2 integrals back. We had 2 clues to plug in. So what if we know the initial position? Then my position, whatever that initial position is, would give me that negative 4.9, which is 1/2 of 9.8. 0 squared, that's going to go away. Plus my initial velocity times 0, that's going to go away. My c is just going to be that initial position.
How come you have v sub naught in that t? Is that because you integrated it?
Well, because the only thing I'm saying that we know right now for all of these free fall is the gravity number, but I mean, initial velocity could change. So I'm just saying, well, what is the initial? It'll be different for different problems.
No, but my question is
I missed it.
Yeah, because you have it v sub naught and then times t. So where did you get it?
Oh, I integrated, kid. So integrating this guy up the power, so from a t to a t squared over 2, right? But this guy is like a constant, so he needs his variable. The derivative of a constant is 0, but the integral needs to add a variable.
Okay.
Does that make sense?
Yeah, I was
Got you. Yeah. Because you don't want to just memorize it, right? Even though you have it memorized, probably. So then we can say our position in free fall is equal to negative 4.9 t squared plus v sub naught t plus c. But we did all of this based on Andy saying, hey, choose this one at the beginning. We chose the meters per second. So if we wanted to keep it general and not specific to meters per second, these are the formulas that we would have, but once again, only for free fall, which means only for a constant acceleration. So these ones are just in general given a constant acceleration. And it's like, sure, I guess we could be like physics and we can memorize like a whole chart of formulas. However, at the same time, you can just say like, oh, you're given a constant, we'll integrate it twice and we'll have our own formulas. Either way. But for free-fall models, it might be nice to have like these little formulas written down. So if they did want us to change to something like feet per second squared, no stress. Go put in your negative 32 here and here. No big deal. And it would be negative 32t plus b sub naught, and then negative 16t squared plus b sub naught t plus s sub naught. You guys actually saw these in pre-cal for a homework that you didn't like because you didn't like to read the directions. And you were supposed to be plugging in stuff. It was like a solve a system of equations. You knew 3 positions. You were trying to find the quadratic by plugging in. It was a system of 3 equations. But they just gave you this formula, and they were like, figure out how to use it. Now we didn't just figure out what it is. We also found it ourselves. Just starting with gravity being a constant. So for the rest of this section, we're just going to play, basically. But let me give you guys a second on this slide. For the rest of homework. For the rest of notes, we're going to play. We're going to get some examples in. People that are in the WebAssign already, if you want to find like a tricky one that maybe you're stuck on that we can use as an example to kind of help out in homework, let me know in a little bit. We'll do a couple examples up here first, though. But one of the biggest things I want you guys to understand is for right now, we only know how to do indefinite integrals, integrals without bounds. For right now, the biggest thing I want you to know is we're able to go backwards. Forwards is derivatives. Position, velocity, acceleration. Backwards is integral. Acceleration to velocity to position. And P.S. Gravity is a what again? I was just going to say an acceleration, but yeah. It's a force acting on, that's true. We can think of it as an acceleration because of its units. It's not feet per second. Position, velocity is feet per second squared. It's feet per second. Now's a good time to stand and stretch. Now's a good time to shake it out and maybe grab a couple of donut holes. Now's a good time to get your calculator out and get it ready. We're going to go play with actual problems. That's a good time to take like a 1-minute breather. Let me go in here. Do I still have you in this right chair? Yeah. Hey kiddos, as soon as you see a thrown upward. Oh dear, there's trauma going down back here. Softball girls.
Jeez, Noah, jeez.
Softball girls.
I know, right?
I know, I heard.
I got so mad yesterday.
I heard someone came by and they were just trying to like supervise you guys and just, you know, be there for you and say like, hey guys, how's it going? And just silence and turn away. I was like, ooh.
What?
I know.
I missed the day, but when did that happen?
Poor Kayla. She was just trying to be
Kayla.
nice.
Oh.
She's the one that's been watching you for the last hour.
Oh, that girl? Yeah, we don't ever talk to her.
Yeah.
I didn't know she wanted us to talk to her.
She said hi one time in the senior patio. You must not have been there. She was like, I
That's
said hi,
crazy,
and then they
bro.
just ignored me.
Yeah, she seems nice. I'll say hi to her.
She's a sweet kid. She just graduated college. A ball is thrown upward. Hey! If it's thrown upward, what is it going to be doing? Oh, come on, softball. It's thrown upward. What's it going to be doing? It's going up, but for how long?
Not long.
Not long, because what's going to act on it?
It's gonna come down.
It's going to come down. What am I trying to say? You have gravity.
Because it went up and it came down.
All right. Acceleration is going to equal negative gravity. I guess that is true. Maybe they have gravity be like an absolute value too. The acceleration is negative gravity, which is going to go ahead and be... Hey guys, why am I writing in the negative 32 one? Andy and Josh, help me out. Why am I writing in the negative 32 one? It's in feet. Woo! Look at Sarah, stealing the spotlight. Got it.
Yeah, dude. Join physics.
Have fun! You're missing out on the fun. Let's go. You can be doing your web assign right now.
I bet you would love
Wait,
that.
how is it?
What do we?
Love it.
Check it. I'm coming back. But first of all, check it. Why did Sarah say do the feet one? Because it said feet per second. So then we have two different options. This guy or this guy. We're not making up gravity. We're using what's been established. Does that make sense?
Oh, that's gravity.
Yeah.
Oh.
Does that not help?
Why?
No, bro, when you went up there.
No, it's because it's just my boyfriend.
So you.
No one's just laughing.
No one just saying,
We'll
I
be like,
accelerate.
No, I haven't used them yet.
There you go. So gravity is the 9.8, the 32. We throw a negative because it's pulling it down. No, I'm so sorry, I lost him. I let him have too long of a break. Hold on, we're getting him back. We're getting him back. We have two clues. We have an initial velocity and we have an initial height. We have an initial velocity and initial height. So if I just write down these clues, I'm choosing, like Sarah said, my gravity of negative 32. I'm using my initial velocity of 64 feet per second. But wait a minute, why am I making this a positive if this ball's coming down? Why is velocity, the initial velocity, a positive if the ball's going to be coming down? Read the words. No, that's going to make my initial position be a positive 80. It is positive because it's starting, whoa, where is this ball starting from? I don't know, like a building? It's being thrown from 80 feet, so it's somewhere. It's not on the ground. It's 80 feet up, so that's, quite a few of me. Yeah, it's probably at the top of the building. Say the top of the gym, sure. Probably a little higher. Top of the gym. A ball is being thrown how? Upward. There's my positive velocity. It's not being thrown down. That would be a negative initial. It's being thrown up, a positive initial velocity. But even though it's being thrown up, Andy, help them. They're not in physics.
Yes.
Even though the ball is being thrown up, so the initial velocity is positive. Why is it acceleration still negative? Because that force is pulling it down, right? The ball can be moving up with a force that's pulling it down that will eventually counteract that initial velocity. And as Sarah said, it's coming down. What's going on with part A? Rocco,
They're
focus.
asking for position.
They're asking for position. Could I, right now, could I take the time to say, well, okay, we have acceleration. To get velocity, we go backwards by taking an integral. Could I do this work? Some of you were like, I'm not writing that down. She's sounding like she doesn't have to be doing this work. The question, could I be doing this work? Could I be saying that gravity is acting on this ball?
Yeah.
If I say gravity is acting on this ball, don't I integrate acceleration to get velocity? And can't I plug in my clue like we did in homework? And can't I say, okay, so this is going to be 64 when time is 0. So C is 64. And then could I be writing that velocity is then equal to negative 32t plus 64? But cool kids, number 1, that's not what they're asking for. And number 2, did I have to show all my math even though I could once I showed it to you once over here? What are you allowed to use now that I've shown you, given any constant acceleration for free fall, that is negative gravity? Can't you just say, well, I know gravity and I know my initial velocity, so I'm going to plug in? Go team! Do you see it? Now, the AP is probably not going to ask you one of these. Maybe the physics exam would, but the AP calculus wouldn't, because they want to see if you could do the integration. They wouldn't give you a constant acceleration, probably. But that doesn't mean that we shouldn't talk about these problems still, because we know where the formulas come from. But I'm just saying, this is the math behind it, but I already showed it to you once. Plug in your gravity, plug in your initial position, and then say, oh, hey, cool. But wait, we don't want, initial velocity. But what did they actually want for part A?
Position.
Man, was all of that work wasted?
Oh.
Position builds off of velocity. If I was doing it, I would have needed to take the first integral to be able to get something to take the second integral of. If I was doing, once again, the math of it all. And I would integrate, and I would get negative 32 t squared all over 2, which is the same thing as negative 1/2, gravity t squared, plus 64t, plus c. I would need to come up and say, hey, I have another clue. And I would have to get that clue, and I'd have to plug that in and say, so that means that 80 will be the position when, well, negative 32 over 2 times 0 squared is 0, plus 64 times 0 is 0. This is my initial. Oh, cool. So C is 80. But check it. Didn't you have a cool formula? And like Sarah said, even though my math is going to get me, take this function and plug in your C. Even though my math is going to get me negative 16t squared plus 64t plus 80, even though it's going to get me my position formula, couldn't I have just taken this and said, oh, hey, I'm going to take 1/2 of my acceleration, which is negative gravity, or negative 32. 1/2 of negative 32 is 16t squared, plus my initial, which was 64t, plus my initial, which was 80. Once I show you the math once, you can use and plug and chug. Guess what? Part A. I boxed it. Why? Because I got to my position. Cool? We okay? Use the math, take the integral, or use the formula. It's free fall, plug and chug.
Question.
I'm going to answer that question, Andy, but for those that are like, no, I got it, just check out what we're supposed to do next, given all that we've done in A. They're asking for when the ball hits the ground. Andy, go ahead.
So, you know how you took the integral for velocity? Would you always have put that step, or could you just go straight to it?
If it's a free fall model or a constant acceleration, I mean, I've shown you the math once. It's always going to land here as long as it's a free fall model and or a constant acceleration model. So you can plug in. Yeah, for our homework. I'm just warning on the AP. They're not going to make it to where it's one of these simple physics memorized ones. They're going to make it to where it's not constant, so I need that integral. Does that make sense?
Yeah.
But in this homework, I mean, it's free fall. So yeah, it's going to be the same thing every time. Why make you do it like 20 times? So what do we do given all this? That we could have plugged into for that and that. But I showed the math also. What do I do if it wants when it hits the ground? What equals 0 though? But yes, careful. Final what? Position is the ground. I know, you're going to want to say velocity when you hit the ground. Your velocity is 0. No. After you hit the ground, your velocity is 0. When you hit the ground, you're going splat because you're hitting it with a speed. You're hitting the ground with the velocity. It's that split instant after you hit the ground that your speed is 0, that your velocity is 0. So as you hit it's one of the hardest, the most confusing, or I should say the easiest missed concept in all of motion. Hitting the ground, the velocity is definitely not 0, or else no one would ever get hurt and nothing would ever break. If you hit it not going any speed, you're fine. Which is why accidents, when you're like at a stoplight, stopped, and someone, well, this doesn't sound, but like if you're in city traffic, and you were just taking off from a stoplight and someone behind you bumps you, like you're fine. They're fine, usually. As long as you both were stopped and like that accident happens in that split second, because there's not that buildup of speed. If you have a very low speed or no speed, there's no damage. Okay, so coming back. Velocity is not 0. Position is. I have to set position equal to 0 when? Go grab your position formula and set it equal to 0. And why are some of you going to be like, oh. What's this equation? It's a quadratic! Oh. Was anybody in here this morning when Isaac Leverton came in and needed to factor a trinomial? Right? You've been there, you've done that, but you still don't like it. I need to factor, good old-fashioned trinomial factoring. Now some of you might be grabbing out your calculator, but let's see if I can beat you, because 16 comes out of everybody. 16 goes into 64 4 times, 16 goes into 80 5 times. When is this going to hit the ground? Well, I'm going to have a t minus 5 and a t plus 1, how do I know from all of this that's going to hit the ground after 5 seconds? Someone connect the dots. How do I know it's hitting the ground after 5 seconds? What have I done? Where's my math? 5 minus 5 is 0, so t equals 5 is a 0, but what's the other 0? I thought there were 2. Negative 1. Well, wait a minute, how does that make sense? Are you sure it doesn't make sense? The ball's being thrown off of like an 80-foot something, and it's going up and it's coming down. I'm saying it's coming down, this is time, after 5 seconds. But guys, mathematically, doesn't it make sense, parabolic behavior, that the math would give you another 0? Now, does that make sense as far as can that be the later time when it hits the ground? No, you're holding the ball on top of the building or whatever. It's not even doing this motion, but mathematically, it's not crazy that there are 2 answers in the math, but in the situation, that negative doesn't make sense. If that's what you meant, I agree. But the math makes sense. Yeah, parabola will hit twice, but it doesn't make sense in the situation. Dun, 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 dun. My calculator people, I think I beat you. Moving on, next example. So many people on your computers, very dangerous. Make sure we're getting these notes and these examples, or else I shall not be happy. Hey, this one they tell us exactly what to use, but can we talk about the situation and what's easy, what's hard? Map it out for me. What are we talking about? Give me what you know, then we'll talk about what you need to find. You're throwing a ball upward from the ground. We'll do a vector to show something being thrown. Where do you need that ball to go? Top of the Washington Monument. I need it to hit what height? Check it. Something over here was thrown upward with an initial velocity of 64 feet per second. Well, actually, we didn't see how high it went. Never mind, that's not going to help so much. I don't think it's going to reach the top of the Washington Monument, though, and it started at 80. This one's starting at 0. Label what you know. You have 3 different things you can set that equal to. Technically 4. 4 variables in motion. Is it a T, an S, a V, or an A? What is that 555 feet? Is it a time, a position, a velocity, or an acceleration? Position all the way. Is it speed?
That's like retaking the cloud.
I know.
Hey, cool kids. Who's this dude?
Acceleration.
Uh-huh.
Super.
This is free fall. There's no little motor on it. It's only one-dimensional. You're trying to throw it straight up to someone at the top of the Washington Monument. Not literally, there's not someone standing on top of it, but you know what I mean. To see if it goes that high. So what can I say? I can say my acceleration is constant. Andy and Sarah, you ready? Let's just plug it in. If we just plug it in, my velocity is going to equal, I remember the formula, by an integral plus the initial velocity is, oh no, I don't know. Now I'm going to name it V instead of V sub naught, because when you start putting little subscripts, people don't like it as much. I'm just going to say V for the initial and just whatever, deal with it. And then my position is equal to negative 1/2 of that gravity. So negative 16 t squared plus that initial that I don't know plus, what's my initial position? Where is it starting?
0.
Yeah, it's starting from the ground, so that's just going to be 0. So I get to actually say that that initial position isn't a big deal. Now check it. Base up here. I want that to equal 555. But think about the math. If I don't know the initial, and I don't know the time, how on earth am I supposed to solve that bottom equation? Is it possible to solve a 2 variables with one equation? No, chapter 7 in pre-cal last year. You need 2 equations to solve for 2 variables, 3 equations to solve for 3 variables, 4 equations to solve for 4 variables. But don't I have another equation? But they didn't tell me anything. No, but physics could. So could math. If I make this the top of this guy's motion, and if I drag this out over time, what's happening as it, starting at 0, wanting it to go to 555, talking about the time and talking about the position. If I just need it to make it there, I'm going to make it my maximum height. Tell me about the calculus. What do we know about the derivative at the max? It's 0. I have 2 equations, 2 unknowns if you put it together. Or in physics, you might talk about some sort of like in between changes of direction going up and going down, you're going to have an instantaneous stop or an instantaneous 0 at the top of the motion. In math, it's like, well, duh, it's a horizontal tangent line. You could also think of your intermediate value theorem in the sense of that ball is going up, 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 and at this point, if that's the highest it goes, it switches to going down, 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 down. Question, from a positive velocity to a negative velocity, what does there have to be in between a positive and a negative? A 0. IBT. So all of a sudden, cool kids, you're back in pre-cal. Why? So you just need to solve a 2-system set of equations where you have negative 32t plus v is equal to 0, and negative 16t squared plus vt is equal to 555. And if I were you, don't do elimination because you don't have enough like terms to get stuff out. But what you could do is a good old-fashioned substitution and say, hey, why don't we get v and why don't we plug and chug them? So v is equal to 32t. Plug it in, and then I end up with negative 16t squared plus 32t squared equals 555. It's pre-calcul, kids. 16t squared is equal to 555. My t, I need the positive time. I don't want the negative time. That doesn't make sense. I want the positive time moving forward from after the throw is going to be the positive square root of 555 divided by 16. Now, some of you might just about now be saying something to the effect of, but wait a minute, didn't we want how fast the ball needed to be thrown? Not when it would hit its max? Well, let's find the when. Which would be 5.8896. On a calc exam, you would always keep 3 decimal places, but we're going to keep more because this is not the final answer. That's how long it takes. But guys, if they want how fast it needs to be thrown, who am I actually looking for? Is there anything on this page that if I know the time, I can find the velocity? Dun, 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 dun. Multiply by 32. That ball would need to be thrown with an initial velocity of 188.468 feet per second to reach the top of the monument. For those of you that are like, ooh, systems of equations, I like those. These dots should connect quickly, but for those of you that like systems of equations, there's a lot of algebra math plugging in. It might have gotten a little bit dense there at the end, but remember it's in the recording. If/when you might need that to help you with homework. Speaking of homework, I have other examples, of course. But one of your classmates was already playing around with this homework, so I'm going to freeze the screen real quick for everybody still looking at it. And they mentioned that number 2 had tripped them up just a little bit as far as making all the matches. So I'm pulling number 2 from WebAssign on the screen right now. Homework problem, number 2 from this section. You guys ready? Do it in your notes and you'll have pointers even, well, you might even have the solution. Let's get what we can in the last few minutes of class to help you guys on homework. Set the scene. Set the scene. Acceleration is equal to, oh, cool. Use the feet one. All right, whatever. Here's my acceleration, and that's just from gravity. Okay. Neglecting air resistance. A balloon rising vertically with a velocity of, let's underline our important stuff. What do we know? With a velocity of 16 feet per second. Ooh. This is like a hot air balloon. The hot air balloon is releasing a sandbag at the instant when the balloon is 80 feet above ground. This is more exciting than just a normal balloon. Releases a sandbag at the instant when the balloon is 80 feet above ground. So have a hot air balloon. People are in it having tons of fun. They're up there, right? They release a sandbag off the side. This sandbag is going to be falling down. Unless they throw it up. Did they say anything about them throwing it up? Or throwing it down? It just says releases, which is very similar to drop, right? They drop it. So I'm dropping a sandbag. So isn't that 80 feet where my sandbag is starting from, guys? Do you guys agree? It's starting from 80 feet up on the ground, it's coming down. Even though the people in the balloon are dropping it, why am I going to make the initial velocity 16 feet per second? The people did not throw that thing up in the air. But why am I saying at the instant it's being dropped, its initial velocity is 16 feet per second? Why does that make sense? Oh yeah, the balloon is rising with that speed, and so that sandbag, the instant it's dropped, even though gravity's going to take over very fast, that thing's going down. It does have that instantaneous upward thrust of the balloon that's rising. So I get to steal the balloon's initial velocity, even though there's no like outside pushing down or throwing up. That's happening as it is released. What's part A asked? Does this look familiar? Does that look familiar? Strike the ground. The clue isn't hard once you get used to it. What's hard is like, but who's my position? Oh, we have formulas, right? We have formulas where we can say with our constant acceleration of negative 32, they told me this. We could take an integral, but that integral would give us the negative 32t plus my initial velocity, which we kind of talked about, is 16. My units are all feet per second. I'm doing all right. So my position, I could plug in. Ooh. Trying to do the whole formula. Negative 16t squared plus 16t plus my initial position. Oh, guys. It's just a quadratic again, right? So maybe the problem we just did was enough to help you with this guy. So I'm just setting him equal to 0, and I think I'm just going to be doing like a little bit of factoring stuff, right? Factor. Take the time that works. But what's going on in part B? That was super similar to the example we did 2 examples ago, but this one says, at what velocity will it strike the ground? If you put 0, you are horribly wrong, because if someone's standing underneath that sandbag, they're not going to say it hit them with a speed of 0, right? We need to figure out, hey, what is this time from this guy, t equals? We're going to find that time by factoring and setting equal to 0 and choosing the positive one. Then we're going to have to go ahead and say, well, let's plug it in to the velocity to know part B. Part B says, let's plug it into velocity and find that guy. Part A says, what was the time to begin with? Has anybody factored and want to share with the class since the bell has not rung yet? What happens when you factor? Doesn't negative 16 go into everything? Oh, what's wrong, cool kids? I think negative 16 goes in, doesn't it? That goes in 1 time and it goes in negative 1 time. And did you guys figure out it was 5 times? Oh my goodness. I think it's kind of like the one we just did. Oh, except this one. Struggle bus. Can you factor like that? that nicely. You can use a quadratic formula. Hold on. They're telling me to use decimals. If they're telling me to use decimals, couldn't I be putting this quadratic in my calculator? Now, maybe with 80s and stuff like that, I would not want to put that in my calculator because my window is going to be a mess. But what if I was to put this in my calculator and I was to, hold on, Mo, I got you. What if I was to put this in my calculator and just say, I need the zeros of this nasty quadratic guy? We can totally do that on a graph, which is why when we get into further AP practice, we're going to have to make sure you guys can use your grapher because, guys, the zero is right there. Do you remember how to find it with your second trace feature? If you're doing decimals, don't go doing a quadratic formula. Just go say, hey, I can find the zeros on my, check it. I'm being lazy. I took out that 16 to make it small and nice and neat. But I need to go find that zero. Zeros say go a little bit before. Go a little bit after. Boom, boom. Check it. Super cool feature. You might want to look at this video at the very end to see how to do it. I'm going to hit from that 0 on my graph. Second, quit, stow. I'm going to make it an A. And the reason I'm going to do that is because not only do I know the answer, but I can also go throw it in and say, hey, just put that little A into my velocity and add 16. It's a really cool trick, and I have both answers. Snap, doggy dog. Bye, guys. I'll see you later. Later, gators. Someone text Mo and tell her I say bye. Yeah.